welcome to today's lecture. Today's lecture is all about what? Bonding. Objectives. Firstly, I'm going to start by doing an introduction to bonding. After that, I'm going to teach you about the types of bonding. Lastly, I'm going to do some examination questions that fall under what? Bonding. Now let's look at this interesting part called bonding. So bonding can be anything, but under chemistry we're simply talking about bonding of what? Atoms. What is bonding? By definition, bonding is chemical combination of two or more atoms. So when two or more atoms combine chemically, that's what we're calling what? Bonding. Note that compounds and molecules result from what? Chemical bonding. So when chemical bonding occurs, the products we get are compounds and what? Molecules. Compounds are simply substances formed by two or more different types of what? Elements. Example, sodium chloride is formed from two different types of what? Elements. While molecules, these are simply pure substances that are formed or composed of the same types of what? Atoms. Example, oxygen and what? Hydrogen. So when you look at hydrogen, there is a 2 down there. It's formed from the same types of what? Atoms. Note that only outermost shell electrons take part in what? Bonding. So the only electrons that take part in bonding, they are electrons that are found in the outermost shell of any what? Atom. So these outermost shell electrons are the ones that participate in what? Bonding. Atoms are held together by the forces of what? Attraction or what? Bonds. Note that for any bonding to occur, there must be a force of what? Attraction between the what? The atoms. A bond is a force of attraction between what? Atoms. And this is the thing that makes bonding to what? To occur or to be there. Without the force of attraction, there can't be bonding. Okay, now that we know what bonding is, we need to know why do atoms what? Bond. Or why do atoms form bonds? So atoms form bonds in order to be stable. It's for their stability. Note that atoms react with one another in order to acquire full outermost shells like those of what? Noble gases. These noble gases we are seeing, they are group 8 elements of the periodic table, and they are what? Stable gases. They do not lose or gain what? Electrons, because they are stable. They obey octet rule, unlike helium, which obeys duplex what? Loop. So the reason why atoms react is because they want to be stable like what? Noble what? Gases. Or they want to acquire a full outermost shells like those of what? Noble what? Gases. So example of an element that is found in group 8 of the periodic table, which is part of the noble gases, is what? Neon. So neon has a mass number of 20 and has the atomic number of what? 10. So if we do the electronic configuration for neon, we find that the first shell has what? 2 electrons. Second shell should have how many electrons? 8. You subtract this from that, we're going to get what? 8 electrons. So this one, there are 8 electrons. And if you can remember octet rule, that's if you have watched the video on electronic configuration. Octet rule should have how many electrons? First should have how many electrons? 2. Second, 8. Third, what? 8. Have you seen this? It's the same as here. So this one, it's stable and it's obeying what? Octet rule. So this neon can't lose or gain what? Electrons, because it's what? Stable. So one of the reasons why atoms react or bond is to acquire a full outermost shell like what? Noble gases, to acquire the full electrons, like obeying what? The octet what? Loop. So for example, lithium, it's a metal. It has 7 as the mass number and 3 as the atomic what? Number. So let's do the electronic configuration for this. So octet rule is saying first you should have how many electrons? 2. 2 is subtract from 3, you're going to have what? 1. Here we're not having something like 8, because second shell according to octet rule should have how many electrons? 8, but it's having 1. So this one is a metal, so meaning lithium should lose this electron so that it can be what? Stable. So this one can react with other elements or can bond with other elements in order for it to acquire a full outermost what? Shell, like what? Noble what? Gases. I'm sure that's what clear to you. Okay, now let's look at this interesting part, types of what? Bonding. So there are three types of bonding, namely ionic bonding, covalent bonding, and metallic bonding. So let's start with ionic what? Bonding. So the alternative term for ionic bonding is what? Electrovalent what? Bonding. So what is electrovalent bonding or ionic bonding? So ionic bonding involves the transfer of electrons from a metal to a what? Non-metal. Note that a metal loses what? Electrons, while a non-metal gains what? Electrons. Formation of ions. So this part is very much important under ionic what? Bonding, because ionic bonding involves interaction of what? Positively charged ions with a negative charged what? Ions. So there are two types of ions, namely positive ions, which we call cation, and negative ions, which we call what? Anions. So now let's look at positive what? Ions. So metals form positive what? Ions. Meaning metals lose what? Electrons. So when metals form positive ions, it's just an indication that they lose what? Electrons. So when metals lose electrons, they form positively charged what? Ions. Examples of positively charged ions are sodium ion, like this. This plus you are seeing here, it's an ion. It's an indication that sodium loses what? One electron, and it's placed in group 1. So all group 1 elements, they lose what? One electron. Same with what? Lithium. So when you see on a periodic table, lithium and sodium, they are placed in the same group of the periodic table. That's the reason why they are having this plus 1, meaning they lose one electron because they are metals. When you look at aluminium, these three are seeing plus. This 3 is a charge, while this is an ion. So aluminium loses 3 electrons. Calcium is in group 2. So it loses how many electrons? 2 electrons, for it to be what? Stable. So an example how these things are formed is like this. So this is an ion. So sodium atom is like this. So it's in group 1. So I'll just indicate like this as an electron, or I do this, but this is same as 1. It's okay. So this, it will turn into what? An ion, which will form, since sodium is losing what? One electron. So even if I don't indicate 1, this is just same as 1. So it will be like this. So this is an ion. This is a sodium ion, while this is a sodium what? Atom. Same applies to this aluminium. Aluminium, it's a metal like this. The symbol is Al. So it loses how many electrons? 3 electrons to form this plus. So it looks like this now when it has what? Lost what? Electrons. So same applies with calcium, same thing. So calcium, the symbol is Ca, like that. So it loses how many electrons? It's in group 2. So it loses 2 electrons to form a what? An ion, a positive charged what? Ions, which looks like this. Say 2 on top, like that. So you need to know this. This is very much what? Important. Okay, now let's do an example so that you can understand what I'm doing. So the question is saying illustrate the formation of ions of the following given what? Atoms. So I'm going to illustrate for sodium, magnesium, and then for aluminium and lithium you can do it on your own. So let's start with sodium. So sodium now, let's try to illustrate. So first and foremost, you need to know the symbol for sodium, which is Na. The mass number is 23 and the atomic number is what? 11. We need to know this. This is very much what? Important. So another thing, we're not supposed to forget the octet rule. First shell should have how many electrons? 2, second 8, third what? 8. So this thing is very much what? Important, even under what? Bonding. So let's start now. So sodium, it's Na, like this. First shell should have how many electrons? 2. So we're going to use this atomic number as in here. So 2 electrons first shell, we subtract from 11. So, and then second shell should have how many electrons? 8. So we have already subtracted 2 from 11. We remain with how many? 9. So second shell should have how many electrons? 8. So 2, 4, 6, 8. So this second shell is what? Stable. And then let's do the other one, because we remain with 1 electron now. Remain with 1. And then that one we can put it any at any point. So this is 1 electron. But under octet true, third shell should have how many electrons? 3 electrons. But this third shell is having 1 electron. So sodium, since it's a metal, should lose this electron for it to become what? Stable. So when this electron is lost, we're going to have 2 electrons which are what? Stable, which are obeying the what? The octet what? Loop. So it's going to be like this. We need to show how sodium will look after what? Losing. So when sodium loses this electron, this shell would disappear, and sodium will remain with how many shells? 2. So we write Na here, like that, and then you write another second one, like that too, and then like that. So note that the other shell has disappeared because it's losing what? 1 electron. So note that it's losing, because it's a metal, it's losing 1 what? Electron. And then you need to put this to brackets like that. So it's losing what? 1 electron. So here you're going to write positive like that. Note that this is a sodium ion. This is sodium ion. The symbol is what? Na plus, like that, meaning it has lost what? 1 electron. And then this is sodium, this is sodium atom. So have you seen the difference between a sodium atom and an ion? And then the symbol is just Na, like that. And then the electronic configuration for this one, so the electronic configuration is what? 2, 8, and then 1, like that. What about this one? It's an ion. Electronic configuration for an ion. They can even ask you that. So first choice having what? 2, second what? 8. There's also what? An electron. So I'm sure for this one it's clear. So let's do for magnesium now. So the same thing. Okay, so we're going to do the same thing from doing to magnesium. So let's start with the symbol. So the symbol for magnesium, it's what? Mg. The mass number is what? 24, while the atomic number is what? 12. So you need to be familiar with what? The periodic table. So let's start now. So the symbol for magnesium is what? Mg. Then the first shell should have how many electrons according to octet true? 2 electrons. So it's 2, you subtract from 12, you remain with 10. And then the second shell should have how many electrons? Should have about 8 electrons according to octet true. So I'm going to write 8 electrons here. So 2, 4, 6, 8. So for this second shell is stable according to octet true, it's having 8 electrons. Now 8 plus this 2, it's 10. So you subtract from this, you remain with the other what? 2 what? Electrons. So in the third shell, we remain with how many electrons? 2. You can place them anywhere if you want, here, anywhere. So 2 electrons. Now according to octet true, first shell 2 electrons, second 2, third, second 8, third 8. Now in this third shell, are these electrons here 8? No, they are 2. So meaning is magnesium is not stable. In this third shell, we must have about 8 electrons according to octet true, but we have into, meaning magnesium is not stable. So magnesium should lose these 2 electrons so that it can remain with these 2 other stable what? Shells which are obeying what? Octet what? Loop. So magnesium is going to lose 2 electrons. So it's losing 2 electrons. Don't forget that metals lose what? Electrons, while non-metals gain. So this side I'm going to show you how this magnesium atom will look after losing these 2 electrons. So that this third shell will disappear. We're going to remain with these two stable shells. So this side I'm going to illustrate or show how this magnesium will look. So it's having 2, the first one, then the second one it's having what? 8 electrons. So, and then this one is having, so magnesium, it's losing how many electrons? 2. So here on top we're going to show 2 plus. So this 2 plus is just showing that it's losing how many electrons? 2 electrons. And don't forget that metals form positive charged what? Ions. So this one here we call it magnesium. Magnesium what? Ion. So this is what magnesium ion is. And then this one is magnesium what? Atom. Magnesium atom. And then the symbol for this one is just Mg. And then the symbol for an ion is what? Mg2 plus, meaning this one just lost how many electrons? 2. Then the electron configuration for magnesium ion is what? First shell is having how many electrons? 2. The second shell is having what? 8. It has lost 2 electrons. So this is the electron configuration. Then for magnesium atom is what? First shell is having 2, second 8, third 2 electrons. So have you seen the difference between magnesium atom and magnesium ion? So they can even ask you to write the electron configuration for magnesium what? Ion, this one. So this is how you do it, and you do the other last 2. You can do it on your own. So now let's look at negative what? Ions, and I'm sure you're clear about the positive ions. So non-metals form negative ions, meaning they gain what? Electrons. If you can remember clearly what I said about the positive ions, I said metals form positive ions, meaning that they lose what? Electrons. So this is just the opposite of the other. And then when non-metals gain electrons, they form negative what? Charged what? Ions. And then for metals, if metals lose electrons, they form positive charged what? Electrons. And I'm sure you're clear on that one. So if you know for negative ions, it's just the opposite for the positive what? Ions. Examples of negative recharged what? Ions. We have chloride, this is an ion. We have fluoride, this one, and we have nitride, and we have what? Oxide. So for chloride and nitride, these things are coming from group what? 7. So this chloride is coming from chlorine what? Atom. This fluoride you're seeing is coming from what? Fluorine what? Atom. So these two, they are in the same group. That's why you're seeing -1 there as a power, -1 as a power. So this is a sign that they gain 1 electron for them to be what? Stable. They gain what? 1 electron. And these two are in group what? 7. So how do I know the number of electrons group 7 elements should gain for them to become stable? We need to know that the total number of groups is what? 8 on the periodic table. And then chlorine and fluorine are in group what? 7 of the periodic table. They are in group 7. So for me to know the number of electrons chlorine and fluorine should gain, I should subtract this 7 from the total number of groups, which is 8. So it's 1. So this thing you are seeing here, that's where it's coming from. So this one was like this. Chlorine, the symbol for chlorine is that one, and then it's losing 1. It's gaining 1 electron. It's gaining 1 electron like that. And then it's going to form a chloride what? Ion, which will look like this. It has gained 1. You can't write 1 in front like that, or even just write in this for electrons, okay, without this one here. And then same applies with what? Fluoride. So fluoride, there was something like fluorine like that, and then 1 electron. It's gaining 1 electron to form this fluoride. So this is an atom, this is fluoride. This is chlorine atom, this is chloride ion. And then when we come to this one, where is this 3 coming from? Note that nitrogen is in group what? 5. Nitrogen is in group 5 of the periodic table. So how do I know the number of electrons nitrogen should gain for it to become stable? I need to subtract this 5 from 8, which is going to give me 3. So this is a 3 you are seeing here. So nitrogen should gain 3 electrons for it to become what? Stable. So nitrite is just an ion for nitrogen. So nitrogen, the symbol is Na. So it's gaining 3 electrons to form nitrite ion like this. So this means that this is an ion for nitrogen, and we call it nitrite, and it must, so it means gaining 3 what? Electrons for it to become what? Stable. So you need to know this, and then you can do that for oxide. Oxide is coming from what? Oxygen. Okay, now let's do an example so that you can understand what I'm from doing there. So question is saying illustrate the formation of ions from the following given what? Atoms. So we are having chlorine, oxygen, nitrogen, and what? Carbon. So we want the ions, formation of ions from these atoms. So let's do it, and I'm going to do for chlorine and oxygen. Then for nitrogen and carbon, you can do it on your own. So chlorine. So chlorine is in group what? 7 of the periodic table. So we need to know the symbol for chlorine. It's Cl like that, and then it has the mass number of 35.5 like that, and then it has 17 down like that. And note that these are non-metals, so they gain what? Electrons. So let's start with the symbol for chlorine. So chlorine has Cl like that. According to octet rule, the same thing, you should have how many electrons? 2 electrons first. Then second should have how many electrons? 8 electrons. So from 17 I've already subtracted 2, I'm remaining with what? 15. So second should have how many? 8 electrons. 8 electrons. So I'm sure 8 electrons are done. So 2, 4, 6, 8. So plus this 2 inside, that's 10. 10 you subtract from 17, we're remaining with 7 electrons. But third shell should have how many electrons? 8 electrons. So we're having 2, 4, 6, 7. But this last shell, it's not stable because it should have how many electrons? 8. Remember octet rule. First shell 2 electrons, second 8, third what? 8 electrons. So the last shell is not stable. So meaning chlorine should gain 1 electron for it to become what? Stable. So it's a non-metal, it should gain 1 electron so that it can make it work to what? 8. So this side I'm going to show how chlorine will look after gaining what? 1 electron. So here chlorine is gaining 1 electron. So let me show how chlorine will look after gaining Cl. So 2, second shell 2, 4, 6, 8, and there is a last shell here like this. So 2, 4, 6, 7. Have you seen that? Now here I'm going to show how chlorine will look after gaining. So chlorine should gain what? 1 electron. So 1 electron, I'm going to do it like this. It should gain 1 electron so that this one can obey the octet rule. It should have how many electrons? 8, not what? 7. So this side now it's gaining what? 1. So here I'm going to write just -1, like just negative like this, same as 1, not 1 negative, just this, which means it's gaining what? 1 electron. So note that this is we call this one as chloride ion. This is chloride now, chloride ion. The symbol is what? Like this. Then the electronic configuration for this one, first shell is having how many? 2, second 8, third what? 8. Just like that. and I'm sure you are clear on this one. Now let's come to this. So this one is chlorine atom. This one is chlorine atom, and then the symbol is just Cl like that. Electronic configuration for chlorine is first choice having 2, second 8, third what 7. So have you seen this 7 here? There is 8. So this one, it has gained 1 electron. So you need to know this. This is what very much what important. So okay, now let's do for oxygen. So we need to know the symbol for oxygen, which is O, and oxygen has the mass number of what 16, and it has the atomic number of what 8, like this. So you need to know this, which is very much important. So let's start now. So I'm start with the symbol for oxygen, which is O. Then first shell should have how many electrons? 2 electrons. So I subtract 2. I've used 2 from 8. I'm remaining with what? 6 electrons. 6 electrons. So I'm going to have something like 2, 4, 6. So I'm done. So 2, 4, 6, 8. I'm done with what? 8 electrons for what? Oxygen. Now this second shell should have how many electrons according to octet rule? 8 electrons. Remember, octet rule. First shell 2, second 8, third what? 8. First shell is satisfied with 2 electrons, but second shell, is it having 8 electrons, having 6? So meaning oxygen should gain how many electrons? 2. So there are 2 electrons missing here. So I'm supposed to show how oxygen will look after gaining what? Electrons. So oxygen must gain 2 electrons to make it what? 8 in this second what? Shell. So oxygen must gain 2. Must gain what? 2 electrons for it to become what? Stable. So I'm going to write how oxygen will look after gaining, like this. So then like that, 2 there, 2 here, and then 2 here. So oxygen, it's gaining how many? 2. It must gain 2 electrons. So I'm going to show 2 electrons here, like this, like this. So it must gain 2 electrons. And then this one, it's even satisfied. It has now obeyed the what? The octet rule, because second shell should have how many electrons? 8, not 6. So oxygen must gain 2 electrons for it to become what? Stable. So here I'm going to write 2 negative, and then note that this is an oxide ion. The symbol is, I'm sure you have seen something like that. And then the electronic configuration, this just means that it's gaining 2 electrons. So the electronic configuration for this oxide ion, first you will have 2 electrons, second 8. But let's come to this we call it what? Oxygen what? Atom. So this is an atom, and then the symbol is just O, like that. And then the electronic configuration for oxygen, first you have 2, second 6. Sorry, second is 6, not 8. Second is what? 6, not 8. So, and I'm sure you're clear about these things. Okay, so don't forget to stream the full video so that you can understand fully on ionic bonding and what? Covalent bonding, and there are some examination questions. Thank you for watching.